All right, algebraic representations of rotations. We have these broken down into three groups: 90 degrees clockwise, 90 degrees counterclockwise, and 180 degrees. Remember, 180 degrees, it doesn't matter if it's clockwise or counterclockwise, you end up in the same location. So 90 degrees clockwise, multiply each coordinate by -1, then switch your x and y coordinate. Okay, so clockwise, remember, you're staring at the clock, waiting for class to end, not in math, but in other classes. And you're watching as the hand goes in this direction, that's clockwise. Counterclockwise is the direction the clock seems to be going when you're sitting in class and waiting for lunch. Okay. 180 degrees, doesn't matter if you go clockwise or counterclockwise, you end up in the same location. So if you're doing clockwise, you multiply each coordinate by -1. You multiply each x coordinate by -1, and then you switch the x and the y coordinates. So when they do this, and this is where it gets a little bit confusing. So you see they had started with the xy, and then they did their transformation, and they ended up with y -x. The y is still your x coordinate. Okay, you still put the x coordinate first and your y coordinate second. But the number that used to be your y coordinate is now your x coordinate. And the number that used to be your x coordinate is now your y coordinate, but negative. Okay, that's a 90-degree clockwise rotation. If you need to listen to that for a few times until it sinks in, go ahead and rewind, try it again. Counterclockwise, same idea, but instead of multiplying the x coordinate by -1, you're going to multiply the y coordinate by -1, but you're still going to do that switch. So xy, your y is now going to be -y, and your x coordinate is the number that was in your y coordinate spot multiplied by -1, and your y coordinate is the number that was in your x coordinate spot. You've just moved it. Okay, we're moving the number. We're not switching it so that the y coordinate comes first. That wouldn't actually change anything. And then 180 degrees is the easy one. We just multiply everything by -1, and that gives us our new coordinate. Okay. So your turn, number 4. Try these on your own before you watch the video, or pause the video and try it. That way you get experience with it, and you can compare your notes and your answer to mine. Also, all of these, you need to be putting all of this in your notes. Okay, algebraic representations of translations, reflections, and rotations. All of that should be in your notes because it will come in handy. You do have quizzes and tests coming up. All right, a triangle has vertices -2, -4, 1, 5, and 2, 2. I like triangles. They only have 3. Squares and things have 4. If we had polygons, many. Okay, what are the coordinates of the vertices of the image after a triangle is rotated? Okay, so we're doing a rotation, which of course that makes sense because this video is about rotations. 90 degrees counterclockwise. So if we look at our 90 degrees counterclockwise, we're looking at this one right here. So we're going to multiply our y coordinates by -1 and then switch our x and y. So I'm going to do this in a couple of steps. So here's our original j was -2, -4. First, I'm going to multiply my y coordinate by -1. So multiply y coordinate by -1, so it's -2, +4. And then I'm going to switch my x and y so that I finish the rotation off. And so this is my final j, is this one right here, the j double prime, 4, -2. Okay, and I'll do that with each of them. K, I start with 1, 5. Multiply my y value by -1. And then I swap my two values. Just like that. And L is 2, 2, which that's fun. L prime, 2, -2. L double prime, -2, 2. Okay, so this last row is our final, where everything ended up. That did not make a square for me. This last row is the one that we're interested in. That would be the answer. J is at 4, -2. Our new K is -5, 1. And our L double prime, or our new L, is at -2, 2. And that would be a 90-degree counterclockwise. If it was asking you to do it clockwise, hopefully you know what you would do. Okay. But that's it for this video.